Okay, now we want to look at processes that lift the air just very briefly, and then we're going to look at clouds and fog also very briefly, because you can go back and look at this at your own speed if you want, and it's also in the book. And we'll kind of go over the different cloud types first, but let's look at how we get air up into the atmosphere. And one of the most common ways is what we call orographic lifting, lifting of air over a barrier. If you've ever been to Hawaii, especially Kauai, and gone on those helicopter trips, you can see this, where if you're on the ocean side of the mountains, it's all lush and green, whereas if you're on the other side, you see it gets much less rain. Here about 486 inches of rain a year, here only about 20 inches of rain. And this is because of this process, orographic lifting. When a moving air mass encounters a barrier and it's lifted up over that barrier. And so on the windward side, it's very wet, the side that receives the wind. On the leeward side, it's very, very dry. And you tend to see deserts on the leeward sides of mountains. Now, this is really, really typical of the northwestern United States. Think of the area around Seattle. Remember last chapter we talked about the ocean currents bringing that water, that had been warmed up as it crosses the Pacific, goes back up the coast of Japan, comes down from Alaska. But importantly, it's giving off heat energy. And so that warm water, that warm moisture rises up and it cools down by expansion. And then it's blown over the land up into these mountains where it's forced up. And as it does so, it's a pretty fast process. And as it does so, it's cooled by expansion, and all that warm air condenses and comes down to precipitation or snow, rain or snow. And so that's why Seattle is so very, very moist. But on the other side, it's incredibly dry there, and you almost have desert-like conditions in some cases. That's orographic lifting. A moving air mass encounters a barrier and is lifted up. Now, once that moisture's in the air, we see it as clouds. And it's just a visible group of moisture droplets that are suspended in the air. Now, fog, it's simply a cloud at ground level, and precipitation is liquid or solid water falling from the clouds. Okay? So there's different types of clouds, but they fall into three main types, if you will, classifications. What we call the low clouds, up to about 2,000 meters or about 6,000 feet. They're the stratus, flat, dull, and gray. If they have moisture, they're nimbostratus. The cumulus, which are bright and puffy, usually an indication of stable weather. And then we call the stratocumulus, which are lumpy, grayish, and low level. Now, if you are familiar with Southern California weather, we get a lot of this. The middle level clouds from 2,000 to 6,000 meters, altocumulus, and what we call lenticular. Very, very high clouds above 6,000 meters are made of ice crystals, and we call those cirrus clouds. Okay, so this is all in the book and everything, and you can come back and watch this, go through it at your own speed if you want, and because I'm just going to click the slides real quick. And there's also a video in the cloud types on the module, so you can, weekly module, so you can look at yourself familiar with the cloud types. So remember, down here are the low clouds, the stratus. Up here are middle clouds, the alto cloud, alto stratus, alto cumulus, these kind of puffy ones here. And then at the top, cirrus clouds. And here's the individual. If it has a lot of moisture in it, it's what we call it's usually going to have what we call a nimbo cloud. So it'll be nimbocumulus, for example, which are our thunderstorms, which we had not too long ago. And we'll get into those later on in the chapter. Okay, so here's just another way of looking at it. So our stratus, we see a lot of these, California, these low gray clouds, the stratus clouds, the altos, and then the cirrus way up here. If they have moisture, here's your cumulonimbus, nimbostratus, for example. Okay? And then, cirrus clouds, ice crystals, above 6,000 meters, about 20,000 feet. Here's cirrostratus. stratus clouds that are very high with ice. Altocumulus are mid-range clouds. Altostratus, see, this is up north of Washington. Stratus, this is right here on the coast of Southern California. These low gray clouds. Nimbostratus, the low gray clouds that have lots of moisture, and if you can see it, you can see the moisture, the rain coming down here. See a lot of these in the Great Plains, which we'll discuss later. Cumulus, you should know this, recognize this. This is Mono Lake, up off 395 on the eastern side of the Sierras. These are cumulus clouds, these kind of puffy, cotton ballish looking ones. And again, they're an indication, if you see these, they're an indication of stable weather. Cumulonimbus, this is in Florida. And again, they're very, very high cumulus clouds that carry lots and lots of moisture, usually indicative of very severe weather, thunderstorms, for example. Notice they're flat at the top because the high level winds kind of shear that off. Lots of energy moving up there, okay? And very, very, you need warm, moist air to do it, lots of warm, moist air, so that our air here is usually cool and moist, whereas down in the Gulf of Mexico, you'll see lots of thunderstorms because the air is warm and moist. That's kind of how it develops. In space shuttle photography, you can see how flat they are at the top. And we'll get into thunderstorms a little later, but notice how massive they are, from 3,000 feet all the way up to almost 20,000 feet. It's a massive exchange of heat energy. Okay, fog, there's different types of fog. Make sure you understand the differences because you're going to get some test questions on that. That's all explained in the book and also in that course module. There's the video on that. Advection, evaporation, upslope and valley fogs, and what we call radiation fog. Advection, very common in San Francisco, just moisture moving horizontally from cold air rising over the heated land rises up and condenses and creates all that fog that we see in California, in San Francisco so often. Evaporation, again, water can store massive amounts of heat energy or heat. So when at night, when it gives that heat energy back as long wave radiation, it's warmer than the air around it, so it condenses very quickly right at the ground, and we see what we call evaporation fog. The valley fog, again, remember from last week with our upslope and downslope winds, the air is trapped in there. The moist air is trapped by the cooler air above it, and it forms this fog in the valleys. Radiation fog, this is the Central Valley in California, so here's the Sierras and here's the coastal mountains. The air, remember on the leeward side, comes down this warm air, and it's kind of trapped in the valley by the cold air coming off the Sierras up here. It's heavier, denser, traps that warm air down, and it turns to fog on the valley floor and creates these very dangerous driving conditions. Up to 5, for example, up through the Central Valley. Okay, so again, fog is just when the air at the surface is saturated. It's 100% humidity, but it's at the surface. So again, advection, horizontal movement of air. Evaporation, the heat from the water body rises up and the cold air traps it down, and we get the fog. Upslope and down valley fogs, again, the result of moist air cooled to the dew point by either rising upslope or settling in the valleys. Okay, so there's your advection fog there in San Francisco, Golden Gate. There's your evaporation fog near the water. Here's your valley ones. Notice the Grand Canyon there. Okay, and radiation fog is where you get the cooling of the ground, chills the air layer above the surface to dew point. And it doesn't occur over water, it only occurs over land. Okay, so that's the difference between radiation fog and evaporation fog, and a really good example of that. Like cold air traps the heat energy rising up and creates that fog in the valleys, Central Valley. Okay. All right, so just go through and watch that the cloud type video there on the weekly module, okay? And then we'll do air masses on the next part.